All right, so welcome back. This week we're going to talk about pandas. So last week we discussed NumPy, and NumPy is a powerful array structure that allows us to manipulate data. But pandas is an additional package that's really powerful, especially among the data science communities. And that's because it makes manipulating data easy. Unlike NumPy, right, pandas uses named columns, so it's easier to remember where your data is coming from. But Pandas, it should be noted, is built on top of NumPy, and it provides a special kind of way, like a two-dimensional data structure called a data frame. And the data frame allows us to give those name columns that I mentioned before, and it also supports robust indexing. So we can go ahead and we can do a standard import. And the standard import that you're going to see over and over again is import pandas as PD. Just like we shorten NumPy, we shorten Panda with the two letters PD. So let's go ahead and import this. Pandas can consume a whole bunch of different types of data, but for this lesson, we're just going to focus on CSVs. It can pull information down from both the internet or a local-based CSV file. There are multiple options on how the documentation can be loaded, and you should see the documentation if you want to see more. So we're just going to load it and accept whatever data types that come in and that it can infer when we load the CSV file. So we're going to pull this information in and then do df.head. df.head will give us the first 5 records of the data set. If we were to create a new cell and do df.tail, we would get the bottom 5 of our data set. You can put any integer in you want here, and it'll give you that number of rows. So I change it to 10, and we can see that we can see the first 10 rows. And this is a way we can peek at our data to see what we have. So we said before that we can access our information by its name. And the way you do that is we're going to use the bracket notation. So df, because that's our data frame, open bracket, and the field name. This will give us what's called a series, which is our one-dimensional array, the column information for the values. And then we're going to use the head again to get the first 5 records. So we're going to the snow depth in centimeters, and then print out head. You can do statistics on each one of these columns, so you can get the mean, min, max. In this case, we're just going to get the average on the air temperature in degrees Celsius, so 6.5 for the whole mean temperature over this. We can go ahead and we can drop information from the columns using the drop method. So you can do df drop time zone and specify that you want to be axis 1. And now when we go and we look at this information, you'll see it's missing. Now, the question is if I do a df.head, will that information be gone? And the answer is no, it won't be gone, because what happened is when we called df.drop, just like when we did those mp dot whatever functions, it creates a new copy of the data frame in memory. So the original data frame isn't changed. So if you're thinking of terms where you have this data set and you need to manipulate it, then you make a mistake and need to go back, this is very handy. So we want to make sure that it goes away. It also, you can do querying just like you did in NumPy. So what I'm going to do is I'm just going to erase this temporarily, and we're going to find the precipitation amount greater than 5. And you can see we get back that Boolean value. We can then go ahead and we can assign that back to a new column saying if it's rainy or not. So if the value is greater than 5, then it's going to get true, and false, if anything lower is false. And we can see that it changed our column from the numerical value to this Boolean value. And then we can go ahead and we can do df. Let's create a new cell. We can do df.rainy, and we can call sum on this series, and we can see that we have 58 rainy days in our data set based on being greater than 5 millimeters. So the next thing that we were playing with, but now we're going to talk about creating it, is the actual series. And series is like the NumPy one-dimensional array. So it's basically a one-dimensional array that contains values. And these values with this pd.series can take, just like we did before, the range, and it can also take other information. And it doesn't have to be just be numeric. It can be Boolean. It can be strings. It can actually be classes of other objects. So if you make a class in Python, you can actually pass it into the Pandas series. And you can do the same thing with NumPy arrays as well. So let's go ahead and create some information. And here we have um, values from 10 to 40 going by fours. And see we get a 64-bit integer. We can then create a name for our series by doing series.name. And what it does is it updates the property that exists on the series to grades. Once we have that, we can then go print out some information about it. And there's different pieces of information, but some of the three most important things to notice are name, dtype, which stands for data type, and size. So when you're investigating the what you have, and you want to know how much you have, you would look at the size property. If you want to know the name of the column, you would just do series.name. And if you want to know what type of data you're actually working with, it would be s.dtype. So now that we have that, it supports slicing, just like in lists and just like in NumPy array. You get everything by your index value. So s brackets the index, you're going to get back the values. And this correlates to the series up here. So the first index is the second item of index 1 is 14, and that's what we got back. We can also do fancy indexing. So here we're going to pull out some values and print it out. So we've shortened our list and just taken out the 0th index position. So the first item and the 6th item, which is the index 5, and we get those 2 grades. We can also do slicing just like we would with lists. We can go and start and do the -2. So we're going to start at the end, go back 2 spaces, and then go to the end. So that's what the colon means. And then we can also, but you can also do things. So like let's say we only have now, if you have an index and the index is 6 and 7 and you put out an invalid index in there, you're going to get an error. And the error is going to look like this. It's going to say key error. And if we go down and we look at it, we're going to say key error 4. And that basically means that whatever index position you're trying to get, that value doesn't exist. So one of the neat things is that Pandas and NumPy work well together. So if you do S2, in this case, this is our series 2, and you do dot values, you're going to get back a NumPy array. So we get that familiar syntax that we saw the week before, and we can see if we put a type on it, we're going to get back that NumPy array. All right. We can also access individual index, so we can see that we have the 64 integer index with the 2 values in it with the dtype of 64. But indexes don't just have to be numerical. You can also have them associated with other things. In this case, we have an index of strings going from A to F, and we can do the same thing that we did before. So here's our index A, B, C, D, E, F, and we can grab a value of 4, and then we can also get ranges. So A to E, we can pull all those values. From B to E, we get all the values from B to E in our index. So that's pretty cool. But then it's still possible to access the data by actual individual index position, even when you have a non-integer based series. So it can be confusing at times because, so let's say we have this following series. We have series Jack, Jones, and James index 1, 2, 3. So let's say we wanted to print the S of 1, so we want to get the second item, or well, the first item in this case. And we can offer attributes of, Panda has these attributes called lock and ilock, and lock uses always the explicit index, while ilock always uses that implicit index. So if we print out 1 here and then 1 here, you're going to see we're actually going to get 2 different results. So we actually get, because of ilock always starts at 0 regardless of what your index is, that 1 position is going to actually get back our index value of 2, and lock, which uses whatever index you have here, is going to get back the value we actually want because we're using that type of index. And then here's just another way of building a series. So what we're going to do is we're going to pass in a dictionary of key value pairs. And what's going to happen is it's going to build the index off of the key, and the value is going to be whatever your value is of the dictionary. And we're going to go ahead and give it the name. And now we have a series of precedents. And notice that even though it's strings, notice that the data type for strings is always object. So this finishes up real quick part 1 of Pandas. We're going to dive in deeper with part 2 and part 3. If you have any questions, please post them in the forum. Thank you.